Good evening, students. I welcome you all to my online class on numerical analysis. So as you know that already we have started with numerical integration and we have completed up to Simpson's 1/3 rule. So only one more result is left, Simpson's 3/8 rule. After that we can solve the problem based on trapezoidal rule, Simpson's 1/3 rule and Simpson's 3/8 rule. So first of all, let's deduce the next result, Simpson's 3/8 rule. So as you know that in order to deduce trapezoidal rule, then Simpson's 1/3 rule, we have taken the help of the general quadrature formula. So in this case also, in order to obtain the Simpson's 3/8 rule, we have to take the help of the general quadrature formula, and we have to take n is equal to 3, and we have to take the curve through the points x0, y0, x1, y1, x2, y2, and x3, y3. So let's start with the deduction just to see Simpson's 3/8 rule. So by the general quadrature formula, we have, so what is the general quadrature formula? It is integral x0 to x0 plus nh, that is y dx is equal to what? It is h n y0. N is the number of interval, plus n square by 2 del y0, the first forward difference, plus it is n cube by 3 minus n square by 2, then del square y0 by factorial 2. The next term is what? N to the power 4 by 4 minus n cube plus n square del cube y0 by factorial 3, and you will get this way, you will get some other terms also. So this is the general quadrature formula. Now let's put n is equal to 3 in this equation 1, and taking this curve, taking the curve through the points x0, y0, x1, y1, x2, y2, x3, y3 as a polynomial of degree 3, so that forward differences of order higher than 3 vanish. So what we'll get, in this case what we'll get, see, integral x0 to x0 plus 3h y dx. So here h you write as it is, so in place of n what you write, it is 3, so 3 y0. So same way n square by 2, you will get 9 by 2 del y0. Just to substitute the value of n is equal to 3, and you simplify the expression. So we have substituted the values of n, and you know that the differences of order higher than 3 vanish, so up to this much term will remain, and the remaining terms will all 0. So if you simplify the expression, see here 3 y0, then you'll get n by 2 del y0, you know the forward difference, it is y1 minus y0. Then here if you simplify, you'll get 9 by 4 after simplifying this, and in the denominator we have 2, so you'll get 9 by 4, and del square y0 you will get y2 minus 2 y1 plus y0. So if you simplify this expression, and here in the denominator 6, you'll get 3 by 8, and the expression for del cube y0 is what? It is y3 minus 3 y2 plus 3 y1 minus y0. So already I have shown how to find out the expression for del square y0. So same way we can find out the expression for del cube y0. So just to simplify this expression, so here what I have done in the next step, I have taken 3 by 8 common. So h is already outside, so if you take 3 by 8 common, so here what you'll get, here you'll get 8. See, 3 by 8 I have taken common, so here you'll get 8 y0 plus after as because you have taken 3 by 8 common, so here you'll get is 12, that is y1 minus y0. Here you will get plus 6 y2 minus 2 y1 plus y0. Then in the last term we've taken 3 by 8 common, so nothing, let me say it is 1. So this expression you will get as it is. So now we'll arrange these terms. So 3 by 8 h outside, so here what you'll get, so first we can write this is y0. So if you simplify 8 y0 with the other terms, and after simplifying you'll get y0, then it is 3 times of y1 plus 3 times of y2 plus y3. So similarly, so first we have taken the points, this x0, y0, then x1, y1, x2, y2, then x3, y3. So for the next 3 points, similarly we can find out the expression for the remaining sub interval. So in the similar manner we can find out the integral for, just to see, similarly we will get the expression. So it is what is the next for the next remaining sub interval, we can write for the next 3 sub interval, we can write it is integral x0 to x0 plus 3 is to x0 plus 6 is y dx. So if you follow the previous result, same way we can write is 3 by 8 h, it is y3 plus 3 y4 plus 3 y5 plus y6. Same way next integral for the remaining next three interval, we can write it as x naught plus 6h plus x naught plus nh. Y dx is equal to what? It is 3 by 8 h, y6 plus 3 y7 plus 3 y8 plus yn. So this way we can continue, and similarly the last integral you will get, it is integral x naught plus n minus 3h to x naught plus nh is equal to what? It is 3 by 8h, then it is yn minus 3 plus 3 yn minus 2 plus 3 yn minus 1 plus yn. So now if you add all these integrals, so if you add all these integrals and applying the properties of definite integral in left hand side, what you will get? It is integral x naught to x naught plus nh y dx. And after adding all the terms in right hand side, it is possible to write this way, it is y naught. So if you observe nicely, y1 y3 y4 y5 will get 3 times. So if you take 3 common, then you will get it is y1 plus y3 plus y4 y5. So the last two terms will be yn minus 2 plus yn minus 1. Then you will get plus 2 times of the terms which are multiple of, you can say 3 6, which are multiple of 3. So you will get y3 plus y6 plus y9. So last term will be yn minus 3. And yn will get single term and y naught also single term. So last time you can write yn. So this formula is known as Simpson's 3/8 rule. So the above formula or rule is known as what? Simpson's 3/8 rule. So based on trapezoidal rule, then Simpson's 1/3 rule and Simpson's 3/8 rule, we have to solve the problem. So these are the three results you have to remember to solve the problem. So what is the first result? Trapezoidal rule. This integral x naught to x naught plus nh y dx is equal to what? It is h by 2 into y naught plus 2 times of the intermediate ordinates y1 plus y2 plus y3 up to yn minus 1, then the last ordinate yn. So this is the trapezoidal rule. And by Simpson's 3/8 rule, what you will get? It is integral x naught to x naught plus nh y dx is equal to what? It is h by 3 y naught plus 4 times of the odd ordinates. Odd ordinates means y1 plus y3, last one is yn minus 1, then plus 2 times of the even ordinate, then lastly you will get the last ordinate yn. And Simpson's 3/8 rule, just now we have deduced this result. See, it is integral x naught to x naught plus nh, then y dx is equal to 3 by 8h, then first term is y naught plus 3 times of the ordinate which are not multiple of 3, y1 plus y2 plus y4 plus y5 and so on. So here last two terms will be yn minus 2 and yn minus 1 plus 2 times of the ordinates which are multiple of 3. So it will be 2 times of y3 plus y6, last will be yn minus 3, and the last term will be yn. So these are the three results you have to remember to solve the problems. So now let me let me explain two problems, how to use these results to find out the value of a definite integral. And you know that numerical analysis, that whatever results you will get, that is the approximate results. So in some cases when you do the integration by calculus, it is possible to find out the results. So the results of calculus we can compare with the numerical results also. So there will be some difference. So that difference is known as the error. So error means what? It is the true value. True value means the value obtained by calculus minus the value obtained by the help of the numerical method. So that one will give you the error. So let's solve the first problem, then it will be clear how to find out the error also. Okay, see the first problem. See, evaluate integral 0 to 1 x by 1 plus x dx by trapezoidal rule, then Simpson's 1/3 rule, then Simpson's 3/8 rule. So we have to find out the value of this definite integral, where the limits of integrations, lower limit is 0 and the upper limit is 1. And this part, you know, x by 1 plus x, this is the integrand. Integrand means this is the function. This function we can write as what? Y is equal to fx. So how to find out the value of this definite integral using trapezoidal rule, Simpson's 3/8 rule and Simpson's 3/8 rule? So for that we have to take the help of the integrand, as well as we have to take the help of the limits of integration also. So just to see how to proceed. So here, what is the integrand? Integrand is what? X by 1 plus x. So this part we can write down as fx. Fx means it is y. See here, y is equal to fx is equal to x by 1 plus x. And what is the lower limit? Lower limit you can write as a, upper limit you can write as b. So lower limit is 0, so we can write a. A means it is the x naught, the first point. When you start with the first interval, the first point is x naught. So a is equal to x naught is equal to 0, and at the end of the interval it is b, so it is x naught plus nh is equal to 1. So we have to divide the interval 0 to 1 into some into number of intervals. It may be 6 also, it may be 7 also, 8 also, it may be less than 6 also. So it's better to take at least number of intervals minimum 6. You can take more than 6 also. So in order to find out the value of h, suppose I have taken number of interval n is equal to 6. So this one I have considered. Let n is equal to 6. We can consider n is equal to 7 also, 8 also, 9 also. It is up to you, but it's better you take n is equal to 6, otherwise it may take time to solve the problem also. So what is the value of h? H is given by what? It is b minus a divided by n. So here you know the value of a and b. A is 0, b is 1, so it will be 1 minus 0. N is the number of interval. We have considered 6, so it will be 1 by 6. So with the help of this, now we have to write down the argument and entry. So remember here the interval, what are the n points of the interval? 0 and 1. And what is the value of h? H is equal to what? 1 by 6. So let's just prepare this table. So here you take the value of x, here the value of y. Corresponding to value of x, you can find out the value of y. Y means what? It is fx. So what is the first point? Say what is the first point? Here x is equal to 0. That means it is x naught. So here if you take x is equal to 0, 0 by something, what you will get? You will get 0, 0. So next you take x is equal to the next point. This is x naught, this one is what? X1. X1 means what? X naught plus h. So what is the value of x naught plus h? So it will get, it is x naught plus x naught is equal to what? It is 0. H is equal to what? 1 by 6. So you will get x1 is equal to 1 by 6. So if you take in place of x 1 by 6, so what you will get? You will get 0.14286. Just to substitute the value here, you take x is equal to 1 by 6 here, and here you can take the help of the calculator and you can find out. You will get 0.14286. So next point is what? X2. X2 is equal to what? X naught plus 2h. So here it will be 2 by 6. So take this value here and find out the corresponding value of y. You will get 0.25. So in the similar manner, you can find out when x is equal to 3 by 6, then the value of y is 0.333. When the value of value of x is 4 by 6. So 4 by 6 means this is x naught, x1, x2, x3, x4. x4 means what? It is x naught plus 4h. So it will be 4 by h because x naught is equal to 0. Find out the corresponding value of y. So this way we can find out the values. We can find out the values of the entries corresponding to these arguments. So once you know these values, then easily we can take the help of these values to find out the value of the definite integral using trapezoidal rule and Simpson's 3/1/3 rule as well as Simpson's 3/8 rule. Okay, now here in this question we have to find out the value of this integral using trapezoidal rule first. So just to take the help of the trapezoidal rule, see here by trapezoidal rule you know the results. It is you can write it is integral x naught to x naught plus nh y dx is equal to what? It is h by 2 into first ordinate plus 2 times of the intermediate ordinates plus last ordinate. So here x naught is equal to 0, x naught plus nh is equal to what? 1, and y is equal to what? X by 1 plus x dx. H is equal to 1 by 6 means you'll get 1 by 12. Then you just substitute the value. See, this is y naught, y1, y2, y3, y4, y5 and y6. Just substitute the values here, and with the help of calculator you just simplify the value of this definite integral. You will get 0.30512. So this way you will get the value of this definite integral using trapezoidal rule. Okay, next let's find out the value of the same integral using Simpson's 1/3 rule. So you know the results for Simpson's 1/3 rule. It is given by integral x naught to x naught plus nh y dx is equal to what? It is h by 3. Then it is y naught plus 4 times of the odd ordinate plus 2 times of the even ordinate plus the last ordinate. So here it will be the integral x naught is 0, x naught plus nh is 1, and y is equal to what? X by 1 plus x dx. Substitute the value of h is equal to what? 1 by 6, so you will get 1 by 18. And substitute the values for this entries. So after substituting the entries, you just simplify, you will get 0.30683. So these values are not same, they are different. So we are getting the value of the definite integral, but the values are not same because these values are the approximate value. Okay, lastly we can find out the value, we have to find out the value of this one by Simpson's 3/8 rule. So how to find out the value of this by Simpson's 3/8 rule? So we have to take the help of the Simpson's 3/8 rule. The result is what? The result, you just to see, it is x naught to x naught plus nh y dx. It is 3 by 8h, then it is y naught plus 3 times of the ordinate which are not multiple of 3. So it is y1 plus y2 plus y4 plus y5, then 2 times of the ordinate which are multiple of 3, you can remember that way, and the last ordinate. So in the same way, you just substitute the values of these entries and simplify, you will get 0.306880. So value of the definite integral using Simpson's 3/8 rule, you are getting this one. See, we are getting 3 different results. Okay, now we can check what is the difference, that means what is the error in this result. So we can find out the value of this definite integral by using calculus. So this is not required. If you are asked to find out the value of the definite integral using Simpson's theory, you can stop here only. Just for understanding, you can see here. So by calculus, what is the value of this integral? Integral 0 to 1 x by 1 plus dx. So if you find out the value of this integral, what you will get? We can write this one. It is integral 0 to 1 plus x minus 1 by 1 plus x dx. So after simplifying, what you will get? It is integral 0 to 1. That is 1 minus 1 by 1 plus x dx. So just to see, integration of dx is x, integration of dx by 1 plus x is equal to what? It is log of 1 plus x. So take the limits. So if you take the limits, you will get 1 minus log of 2. So here you will get the natural logarithm. The base of the logarithm is 2. So if you simplify this one, if you find out the value of this with the help of scientific calculator, you will get this value 0.69314, and 1 minus this, you will get 0.30686. So this one is this value, we can say this is the true value. So this value we are obtained by what? By using calculus. So but if you observe the values obtained by, say, trapezoidal rule, we are getting this value, no, 0.30512, by Simpson's 3/8 rule 0.30683, and by Simpson's 3/8 rule we are getting 30680. So which value is closer to this value? The value obtained by what? Simpson's 3/8 rule. So we can find out the error. So how to find out the error? Error is given by what? It is the true value minus approximate value. So what is the true value? True value is what? 0.30686. This value we are getting using calculus, and this value we are getting using numerical method. That means Simpson's 3/8 rule. So if you take the difference of these two values, say you are getting 0.0006. So this is very, very small. This is very, very small. So this is the error we'll get if we take the difference of the true value and approximate value. So this value is almost same as this value, but little bit difference is there. So that way we can find out the error in the value also. Okay, let me explain one more similar problem, then it will be more clear. Okay, see the next problem, almost similar. See, evaluate integral 0 to 6 dx by 1 plus x. So we have to find out the value of this definite integral using trapezoidal rule, then Simpson's 1/3 rule, and Simpson's 3/8 rule. So exactly same we have to proceed. So first we have to write down the function. So what is the function here, or the integrand? Here integrand is y is equal to fx. Fx is equal to what? It is 1 by x. What is the limits of the integration? See here, a is equal to x naught is equal to 0, and the upper limit b is equal to what? 6. So b means it is x naught plus nh is equal to 6. So here also I have considered the number of interval is equal to what? It is 6. Okay, now just prepare the table in the same manner. So here x means argument and entry. So we know the value of h. So what is the expression for x naught? X naught is 0. So x1 means what? X naught plus h. So it will be 1. x2 is x naught plus 2h. It will be 2. So same way we will get 3, 4, 5, 6. Corresponding to this argument, find out the entry. So how to find out? Just to put these values in place of x and simplify, you will get these values. Now exactly in the same manner. So first we have to find out the value of the definite integral by trapezoidal rule. So you know the results for trapezoidal rule, just now I explained. You just substitute the values of the entries from the table and simplify the expression. So you'll get the value of this definite integral using trapezoidal rule. So here you'll get 2.02142. Again, in the same manner, you apply Simpson's 3/8 rule. Substitute the values for the argument and simplify, you'll get this value. And lastly, apply Simpson's 3/8 rule exactly in the same manner. Substitute the values of the argument and simplify, you'll get 1.96606. So these are the values obtained by trapezoidal rule, Simpson's 1/3 rule, and Simpson's 3/8 rule. So here also we can find out the error. So if you want to find out the error, so first you have to find out the value of this definite integral by using calculus. So if you find out the value of this definite integral, say it is integral 0 to 6 dx by 1 plus x. What is the integration of dx by 1 plus x? It is log of 1 plus x. If you take the limit 0 to 6, you will get log of 7. And this one is the natural logarithm. So the value of this log of 7, you will get 1.945, then 91. So what is the error? So if you see this value, if you compare with the values obtained by trapezoidal rule and Simpson's 3/8 rule and Simpson's 1/3 rule, I think this value 1.95872, this one is closer to this value. So if you take the difference of this value, true value, and the approximate value, this, you will get minus 0.012821. So this is very, very small. So that way we can find out the error, taking the help of the true value and the approximate value obtained by numerical analysis. So this way we can solve the problem using trapezoidal rule, Simpson's 3/8 rule, and Simpson's 3/8 rule. So similar to this, I'll give you some more problems in assignment so that you can practice, and in case if there is some doubts when you solve the problems yourself, then only you'll be able to know which step is not clear. So in that case, you can contact with me, or you just post in the Google Classroom about your doubts, then I can clear it. So thank you all of you.